All right, factoring trinomials part 2. This is another important lesson, as because in the last lesson you looked at a pretty simple way to factor a trinomial like this. The trinomials that we factored last lesson all did not have a coefficient in front, and that method was pretty basic and it worked for those ones. But it's not going to work. That method will not work when we come to questions like this that have a coefficient in front of the first term, like that one or that one, things like that. So when you see a question like this, you can use the video from the method from last video, no problem. But I'm going to show you a different method that will work for every single factoring trinomial question, and it's called factoring by grouping. And factoring by grouping, it's not as cozy as the method I showed you last day. First off, always check GCF. Can we pull a greatest common factor out of these three terms? And there isn't. There's an x, no x there. X can't be pulled out, and there's a 1, a 14, a 48, nothing common between the three terms. Okay, so I know I keep saying that, and I keep teasing that there's going to be one question that you're going to have to pull a GCF out of in these trinomials. Haven't come across it yet. Here's the factoring by grouping method. And this is the neat thing about factoring. There's a lot of different methods. This is just one. This is probably a very common one. I think the textbooks like this example, a way of doing it. There's many different types. This is just one type of but it works all the time. It's kind of old, it's ancient, but it's efficient, it's useful. It works all the time. Okay, so unlike before in the last video where I just put the brackets down and we just figured out, okay, what two numbers equal 48, add to 14, split the x's up, boom, 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 boom. This one you have to do a few more steps. First thing is you want to multiply the number in front, that coefficient, and that number right there. Now, of course, the number right in front of here is the imaginary 1, and that number is 48, so 1 times 48 is 48. So I want to figure out which two numbers, when multiplied by 48, will add to give us 14. Now, most of you are thinking, hey, this sounds just like the other lesson, and it pretty much is. So they have to multiply to give us 48, add to give us 14. 1, 48, 2, 24, 3 and 16, 4 and 12, 6 and 8. And after that, you just get your reflections of those guys. Well, which of these add to give us 14? Not that one, not that one, not that one, not that one. This one, 6 plus 8. Now, the difference is I'm not going to put the brackets in, and I'm not going to put the brackets in and do my thing with this. What I'm going to do instead is I'm going to rewrite this with the 6 and the 8 to show you where the 14 came from. Here's what I mean. So I'm going to rewrite this middle term with these two terms. So I'm going to leave my x squared, and I'm going to rewrite it with the 6 and the 8. So instead of writing 14x, I'm going to show where the 14x came from by writing the 6x plus 8x. I could have put it the other way around, made no difference, then 48. So hopefully you realize what I did there is nothing new. Going from there to there is the exact same thing. It's just, it looks like I'm making more work for myself. Now I factor, greatest common factor. I GCF this. But you think, I can't GCF this. I got an x there, an x there, an x there, but no x there. And you're right, there is nothing I can factor out from all four of these terms. Nothing common to all four of these terms. But if I can take this pair and that pair and factor out each group separately, then I can get something going here. So if I can't do all four, I can do a group at a time. Alright, so I'm gonna what is the greatest common factor that I can pull out of x squared plus 6? Well, they both have an x, at least one x, so I can pull out an x. And when I pull out an x, I'm left with an x. And when I pull out an x out of here, I'm left with 6. That one's done. Now I go to this group. 8x plus 48. What can I pull out of here as a greatest common factor? Well, 8 goes there and there, so I can pull out an 8. And I'm left with x and a 6. Now from here, what is a common factor I can pull out? Now some of you are thinking, what? This looks kind of ugly here. But remember, this x is multiplying that term there. This 8 is multiplying that term there. It's nothing special. You did this back here. It was actually the last example that we did on the factoring polynomials lesson, example 6. You had this right there. We had a common factor of x plus y, and we pulled it out. And that left out this and that. And that's what we're going to do here. And we have all this. It's supposed to be a 6, looks like a b. Both these terms are being multiplied by x plus 6. So that is our common factor, x plus 6. What are we left with when we pull x plus 6 out? We're left with x plus 8. And we're done. Yeah, it's more painful than the other method, which you just did the brackets and figured out that 6 and 8 go there and they go there. But that wasn't the point. The point was to show you how this factoring by grouping works, because the easy method doesn't work when you get down to questions like this. There's a number in front. But it's the same deal. You take the first term and the last term, you multiply them, gives you 10. And now we play the game with the 10. Not the 5. We've got to take care of that 2. So 2 times 5 is 10. What are the factors of 10? 1 and 10, 2 and 5, and that's it. So 2 and 5 are going to work. They will give you 7x. So we rewrite this with, instead of 7x, 2x plus 5x. So you write 2x squared, and we write the 7x to become 2x plus 5x plus 5. We group this pair, group that pair. And we factor out of here. What factors out of 2x squared and 2x? Well, a 2 does, and an x does. When we pull that out of here, we're left with just x. You pull that out of here, you're left with plus 1. What can we pull out of 5x plus 5? We can pull out a 5. When we pull a 5 out of here, you're left with just an x. You pull out a 5 out of here, you're left with just 1. Isn't it neat how you always end up with the same binomial term there? And so they both, what do both these groups have in common? They both are multiplying x plus 1. That is the common factor. We pull out x plus 1. When you pull out x plus 1, what are you left with? Well, when the x plus 1 is gone, you're left with just 2x. And when this has the x plus 1 removed, you're left with plus 5. If you don't believe me, FOIL out your answer, and you'll get this. So that is it. Alright, how about this here? 3a plus 10a plus 7. Again, multiply the first and the second term together, gives you 21. Let's look at our combinations. 1 and 21, 2, 3, and 7, 4, 5, 6, 7. That's it. Which combination works? That one does. So we rewrite this. Instead of 10a, we're going to rewrite it as 3a plus 7a. So 3a, so I suppose 3a squared, my bad. 3a squared plus 3a plus 7a plus 7. There's a group. There's a group. Factor out a 3 and an a. 3a. You factor that out, you're left with just a. You factor that out of there, you're left with just 1. 7a plus 7. Factor out of 7. Factor 7 out of there, you get a. Factor 7 out of there, you get 1. What's a common factor? The a plus 1. They both are multiplying. That group and that group are both multiplying by a plus 1. Let's pull that out as a common factor. You're left with 3a plus 7. And you're done. Trust me. Foil it. It works. Let's keep it going. This time we got a negative sign. This times that. 5 times negative 8. Negative 40. Common factors. 1, 40. 2, 20. 3, 4. 4, 10. 4, 5, 5 times 8. 6, 7. That's it. Okay. Now, they have to equal negative 40. And they have to add to positive 6. So, well, to multiply to give you negative 40, that means one of these two, only one of these pairs is going to be negative. Now, which one's going to be negative? If they're going to add to give you positive 6, is the bigger number going to be negative or the smaller number going to be negative if they're going to add to give you a positive number? Common sense tells you that the one that has to be negative has to be the smaller one. This combination won't work. That combination won't work to give you positive 6. This combination won't. 4 and 10 could. You could write this as 10 minus 4 or negative 4 plus 10. This combination works. Again, if I put a negative there, then the answer would be not a positive answer we wanted. 10 minus 4 will give us this positive 6 here. So we're going to rewrite this with a positive 4x, sorry, a negative 4x and a positive 10x. So, did I do it again? I forgot the squared sign there. Look at that. I hope I didn't do it in the rest of them. Okay. So, this becomes 5x squared, and then these two become negative 4x and positive 10x. There is my rewriting of the 6x. Minus 8. There's my first group. There's my second group. In my first group, I pull out what's common, just an x. What am I left with? A 5x. What I left with here? A minus 4. What's a common factor here between 10 and 8? Well, 2 is. 2 goes into there, gives me 5x. 2 goes into there. Now, what times 2 gives me negative 8? Negative 4. That's how you do that. What's the common factor here? 5x minus 4, 5x minus 4. We pull out a 5x minus 4. What are we left with? X and a plus 2. That is the correct answer. If you don't believe me, FOIL it out, and you'll get that. Keep it going, keep it going, keep it going. I'm going to need more space here. Okay, so multiply to give you 3 and negative 6. That's negative 18. Look at all the combinations. 1 and 18, 2 and 9, 3, 6, 4, 5, 6, 7, 8, 9. No, that's it. Okay. Negative 18, that means only one of these gets to have the negative sign. they have to give you add to give you negative 7. So that means obviously the larger number is going to have to be negative. Well, that one's not going to give you 7, positive or negative. Neither will this one. 2 and 9. Well, who's going to get the negative sign? If we have negative 2 plus 9, that's going to give us positive 7. So this has to take on the negative sign, because 2 minus 9 is negative 7. So we rewrite this, 3w squared. Rewrite the negative 7w with a 2w and a negative 9w. So positive 2w, negative 9w, minus 6. There's a group, there's a group. What's the common factor here? A w. Pull a w out of there, you're left with 3w. Pull a w out of there, left with plus 2. What's the common factor here? Both got negative signs. Let's pull a negative out. 3 goes into both those. And when you pull a negative 3 out of here, another way to think of it is, what times negative 3 gives you negative 9? W. 3w. What times negative 3 gives you negative 6? Positive 2. What's the common factor? The 3w plus 2. So you pull out a 3w plus 2. What are you left with? W minus 3. That's it. Okay. Another variation with the negative signs. So you gotta be careful with the negative signs. Multiply to give you 8 and 1. That's 8. Positive 8. 1 times 8. 2 times 4. And that's it. Which combination is going to give us negative 6 when we add them together? That one won't. This one will. How do we get negative 6? Down 2, down 4. When you do those two, you end up getting 8y squared, negative 2y, negative 4y, which gives us negative 6 plus 1. Let's group this. There's one group there. There's another group there. What's common between this group? 2. 2 goes into there 4 times, and the y squared, actually, sorry, I could have pulled a y out as well, because that had a y as well. So 2y, I'm going to pull a 2y out of there, I'm left with 4y. When I pull a 2y out of here, I'm left with negative 2y goes into itself once. Over here, what's a common factor I can pull out of negative 4y plus 1? Well, nothing can be pulled out. Not nothing. 1 can be pulled out. Now here, this leads us to an interesting little situation. So a 1 can be pulled out. Now I could leave this negative sign here and call it negative 1. That's just the best thing to do. Leave the negative sign there. Pull out a 1. What times negative 1 gives me 4y? 4y does. See, negative 1 times 4y gives us negative 4y. And what times negative 1 gives me positive 1? Another negative 1, because a negative 1 times a negative 1 is positive 1. So you got to be careful with the negative signs. And it doesn't hurt to refoil to see if your answer is right, or you're doing it correctly. Okay, so next what we do is pull out the common factor, which is 4y minus 1. 4y minus 1. Oops, ugly brackets. And you're left with 2y minus 1. Careful on this one. Wouldn't hurt to actually rewatch that one again. That's a tricky one. Alright. You know what? Look at my last example. Guess what? I haven't mentioned it so far, but we can pull out a GCF at the start. None of the other ones I could do that with. That one. I couldn't do it with any of the other examples. This one I can. I can pull out a 3. Because 3 goes into all these terms. 3 goes into there, gives me x squared. 3 goes into there, gives me positive 8x. 3 goes in there, gives me 7. And now, factoring by grouping. So here's what we do. We leave this 3 on the outside. Let's not even worry about it. But let's not forget about it. It's there. Let's just focus on this. Now we have two options. Look, there's no number in front of there. So I can do the old-fashioned easy method of factoring, or I can factor by grouping. If you want to do the easy way, go right ahead. Go ahead and bracket it. I just want to show you the grouping way once more time because I know it's not as easy. Get more practice with it. So the number, so again, we're just going to ignore the 3 and the brackets. We'll handle them later. Let's just worry about what's inside the brackets. And remember, the imaginary 1 times 7, so 7's our factor. 1 times 7 is the only two factors of 7. So how are we going to, what numbers give us, well, obviously 8. 1 plus 7 will give us 8x. So we can rewrite this. And again, if you want, you can, so you don't forget, leave the 3 there. And then we can rewrite this as x squared plus 1x, or just x, plus 7x plus 7. And there's our first group. There's our second group. Again, we'll handle the 3 later. Let's not worry about it right now. What can we pull out of x squared and x? We can pull out a. Actually, it's probably better just to ignore the 3 altogether, and we'll bring it back later because we're going to have brackets and brackets all mixed up. So what can we pull out of this? We can pull out an x. We pull an x out of here, you're left with just x. You pull an x out of here, you're left with 1. What can we pull out of here? A 7. A 7 gets pulled out, you're left with just x. 7 gets pulled out, you're left with just 1. The common factor is x plus 1. You're left with an x plus 7. And now we can bring our 3 back into the game. And we're done. So that is the answer to that one there. Okay, and here are your skill testing questions. Alright, that's it. Good luck, bye.